So it's not B, right? Because it doesn't have a carbonyl.
Right.
And there's a peak. Yeah, okay. Okay, ethanoic acid. And it's not C as well.
Good.
Okay. Is it delta propanol?
Okay. What makes it different from A? I mean, why are you
I saw
choosing
there
B?
was a ketone, and for ketones the absorption range is 1670 to 1740, and it's a strong peak. So I saw that from like around 1600 to 1700 the peak was very sharp. So that's why I chose D, propanol.
Okay. And do ketones give anything apart from this? Can you annotate it on the
Carbonyl.
screen?
Yeah, if you can enable it.
Haven't I already? Oh no,
No.
I haven't. Okay, go ahead.
So for ketone, I'm supposed to annotate.
Sure. Propanone exactly.
So then 16, 14, 1700 and 1740. Yeah, something like this. So it's in between this range. The peak is coming very sharp, strong one
Uh-huh.
because of the C double bond O present in the
Okay.
ketone.
What else?
Okay, what else? How can we find CH3? The CH single bond.
Which one? Go ahead and annotate two.
All right, 2850, 2500, and 600, 2800. This one.
And this says peak is exactly for,
The CH single bond.
and our CH single bond peak supposed to be broad.
CH
Not
single bond
count
is
is
supposed to be.
as sharp, but are you supposed to call them broad?
No, I don't think they're broad.
So which ones are broad?
The broad ones.
Yeah, in the same range.
Broad, okay. So for ketone, you're asking which ones are broad?
No, I'm asking in general, which peaks are
Oh,
broad? Not exactly for
uh,
ketones, but of course the functional group.
the
Which functional
carboxylic
group?
acid one.
Or
Uh, broad. Let's see, broad, essential,
make sure you use
weak.
the old books table and not the new one.
I'm using the specimen data booklet.
Does that use the word broad?
Yeah, for carboxylic acid, the appearance of peak is strong and very broad.
And
That's
do
the
you
only place
remember
broad is
why is it
mentioned.
broad? Because the reason was in the book.
Uh,
That's not a part of the specimen paper or the booklet.
no, I don't think so. I remember.
Okay. Uh, back in the book, I gave
Yeah.
you the previous books table, and they talked about this one, and they talked about this one, and there was something mentioned like this. And for these, they were considered as broad, in which mostly this one is more broad. And that is because of the hydrogen bonding, as mentioned over here. If hydrogen bonding is
Okay.
there, the peaks in IR are supposed to be broad.
Uh-huh. If hydrogen
And
bonding is present.
this is what this means. A is the correct answer to this one, not D.
Uh-huh.
And this sharp
Okay.
peak, does it fall for the same point over there? I think it's 1710 or 1720.
From
This comes out true for
1670 to
ketones.
1740. Yeah.
This is for ketones, but
1670 to
yeah, the one
1740.
you're saying right now, 1670 to
Yeah.
1740.
Yeah, that's for ketones.
Okay. And what about carboxylic acid?
For carboxylic acid, it is 2500 to 3000.
See, 2500 to 3000, a broad peak.
So S means strong means it's what does S mean?
S is strong, W is weak, then there is sharp and broad. Sharp means it's pointy,
Uh-huh.
broad means it's like this, as I've said, plain.
All right.
Okay.
Yeah.
Broad peaks are so such big of an understanding or such big of a point, a hint to go with, that they are easily distinguishable from the rest.
Mm-hmm. All right.
Okay. Also,
Yes,
one of these points might help you. I don't know which one, but one of them can help you with this one. All right.
that's for 1100, 1300. It isn't helping that much.
Mm-hmm. Okay. But I guess this should be A. This should not
Yeah,
be
yeah,
B
all right, I got it.
because of
Yeah, all
being
right.
broad.
Yeah,
All right. And you are facing the same thing in 3.
yeah. 2500. 8. Propanoic acid.
Propanoic acid. And you see the same broad peak in there, which is
Yeah,
such a
broad
big
peak.
characteristic for acids, carboxylic acids, that it's easily distinguishable from the rest. Moving on, 4.
Yeah.
A little tricky, but can be done easily.
Uh, Charlie.
Perfect. Moving on, number 5.
So it's not Beta and Charlie. It's not Beta and Charlie. Mm,
It's definitely not Charlie.
yeah, Charlie it's not. And Beta is a carboxylic acid.
Now, this one
Beta
is
would
going
want
to further help you with the point I explained previously.
yeah, it's
This
not
time,
broad. Yeah.
it is broad, but not as broad as the previous ones were.
Yeah, as it was before. Yeah.
Because if you notice the broadness of the last peak and you compare it with the previous ones, this one
Yeah, it's a
or
big
this one,
difference.
you clearly understand that carboxylic acids were much more broader. So this takes
Yeah, yeah.
B and C out of the
Out.
options. So which one would you choose,
Yes.
A or
Yeah,
D?
just a minute.
If you're using a latest one, that might not be as helpful because
I'm
I
trying to
don't
use
think you're gonna find
data above.
cyclic alkanes over there.
Yeah, it's not there. But I'm trying to use the percentages, like
Uh-huh.
and then I'm seeing the percentages. That's what I'm trying to do.
And does that help?
I'm trying, yeah. Alpha.
Good. Remember, the difference is very minor, and this is a point that we discussed back in the start of organic chemistry, that this one is going to be C6H10 OH twice, of course, since there are two,
Yeah.
and this one is then in turn going to be
Two, four,
C6H12
six, eight,
and then
10,
OH
12. Yeah,
twice.
12.
Okay,
Yeah.
which is trying to make my point over here that this resembles the CnH2n plus 2 method, and this resembles CnH2n method. So the general form for cycloalkanes is same as that of alkenes. This
Uh-huh.
followed this method. Now, if you compare it like this, you'll see this is C6H12, so this is CnH2n, and this is Cn less than CnH2n. This is because that we have added OH on both sides by taking out hydrogen. So that's why this seems like CnH2n, and this actually seems like CnH2n minus 2. So that is because of the substitution we did.
Yeah.
2n, we took out 2
All
hydrogen.
right.
That's why it appears like this. This appears, instead of 2n plus 2, it appears 2n because we again took out 2 hydrogen and substituted them with OH. Okay?
Yeah. All
But
right.
well, for linear or aliphatic alkanes, straight alkanes, branchial alkanes, this is the general formula we go with, no matter what kind of substitution is there, and this is generally for cycloalkanes or alkenes. This is where the
All
part
right.
Cambridge plays the trick for the what was that, functional group isomerism, having the same molecular
All right.
formula but different. Remember, it was also done for alcohols, primary alcohols, of course, and ethers. Like an alcohol and ether can have the same formula. For example, C2H6O, C2H6O, but this one would be actually CCOH, like this, and that's why it would have
Uh-huh.
C2H6O, and this one would then have COC, and it would be something like this. Since we haven't taught ethers in detail in the book, that was a part of AS like 10 years ago, back in 2011 or something. So students usually don't know this, but you will find the exact same example under the heading of topic isomerism and functional group isomerism.
Uh-huh.
So this part
All right,
in
sir.
functional group isomerism and this, that cycloalkenes and alkenes have the same general formula and can be manipulated, have been used in past papers a lot. Okay. Well, this
Okay.
clarifies with because of this percentage that you have already worked out. We don't need to talk about this. But the point I was trying to
Yeah, I
make
worked it out.
before is that OHs have broad peaks, but not as broad as COOH or carboxylic peaks. Carboxylic are the broadest. And they definitely have more
Yeah.
hydrogen bonding since they can lose that hydrogen. That's a replaceable, or we can call it acidic hydrogen, as we already know. In alcohol's
All
hydrogen, the
right.
hydrogen is not acidic. It becomes acidic in case of reaction with sodium, but that's about it.
All right.
Okay. Six. Um,
Delta.
Perfect. Moving on, 7.
Beta.
And why can't it be C or D?
Because for alcohols, the peak is from 3200 to 3600.
And it's broader,
Yeah,
not
it's
sharper.
broad.
Okay,
Yes.
good, good. And yes, beta is correct. Moving on, 8.
Charlie.
Good. And since this is the first ketone peak, you might have noticed that ketones don't have circle or round shaped or broad peaks.
Yeah.
Okay? You might have
Yes.
noticed that they are pretty pointy in all of their peaks, whichever peak is that.
Yeah, that's
So
right.
if the peak is slightly round, this is probably alcohol, and if the peak is too round, too broad, this is carboxylic acid.
Right.
9.
Propanoic acid.
Good. Number 10. And as I said earlier, do not skip these questions. Students tend to skip the questions thinking they might not be a part of paper anymore, yeah, the strategic point of view, that's fine. You won't get any questions like these, but that doesn't exactly mean the specific question that has been asked will not be asked in a different way, like the
Yeah.
previous ones before. So always do these questions. Don't never skip them.
All right, sir.
They're pretty beneficial.
All right. Beta.
In beta, no, I don't think so. Say again.
There is a nitrile. There is a OH. Okay.
Hmm?
Hmm.
There isn't any OHs.
There isn't.
Any OH?
All right, just a minute.
No, there are OHs. Sorry, propanol.
Yeah, yeah, propanol. Yeah,
I assumed propanol. Sorry, my bad. Yeah, of course it would be an addition reaction.
yeah, nucleophilic addition. Alpha.
Alpha, right. All three of them are present actually. And in the
Yeah,
same way said, weak and strong. Okay, Leben.
Beta?
Perfect. There would be no hydroxy peak.
Yeah.
Good. This isn't belonging to the same topic.
Yeah.
That's about it.
All right.